Welcome back, ladies and gentlemen, and thank you for joining us here on our next lesson regarding classes of matter, and this is a review. Let's start with a separation question. How is water recycled and purified in nature? Now, basically, in essence, that is a separation question. How are we separating pure water from the things that could be mixed with it? Dirt, salt, other materials, pollution. Water is recycled and purified naturally in the environment. Let's take a look at how that could possibly happen. It's something we like to call the water cycle.
Most of the time, if we pay attention to clouds at all, it's because of their effect on our local weather. Or maybe it's because they make a sunset prettier. But what you might not know is that clouds affect us every day, even if we're staring at a clear blue sky. The clouds we see when we look out the window are important components of a complex global weather system. They play a key role in Earth's water cycle, carrying huge amounts of fresh water and dropping it as precipitation. And depending on their properties and where and when they form, clouds can have dramatic effects on our climate, influencing the locations and severity of floods and droughts, and even the temperature of our planet as a whole. So by understanding clouds, we can better predict severe storms, the global distribution of fresh water, and the course of climate change. But what exactly are clouds, and how do they form? All clouds share the same basic ingredient: water. They're made up of water droplets or ice crystals that have formed from water vapor in the atmosphere. Although you can't see it or feel it, the air around us contains water even on the clearest summer day. The main sources of this vapor are evaporation, which is the escape of water molecules from the surface of oceans, lakes, and soil, and transpiration, the release of water by plants. As the sun warms Earth's surface, heat is transferred into the atmosphere along with water vapor. The warmer the air, the more moisture it can hold. But warm air doesn't usually stay near the surface for long. Like a hot air balloon, it rises. As it does, it cools. The colder the air becomes, the less water vapor it's able to hold. If the air becomes cold enough, it reaches a state called supersaturation, which causes some of the water vapor to transition back to a liquid or solid state. Water molecules in the vapor form around tiny particles of dust, ice, sea salt.
Nucleation site. I think I remember that from another lesson, whereas the water will not condense unless there's a surface for it to form on.
Serve as the starting point for the formation of water droplets and ice crystals. With this final step repeated billions and billions of times, the water that's been in the atmosphere all along is suddenly visible. And a cloud is born. While we can now see the cloud, the individual droplets or ice crystals are tiny, which is why they remain airborne. But they can combine to form larger drops or crystals. And if they become large enough and too heavy to stay aloft, they'll fall as rain, snow, sleet, or hail back to Earth's surface, where the water in them came from originally.
Okay, so apart from the nucleation sites and the materials, which may add contaminants to the rain, water that has fallen as rain is basically a purified substance. The closest term that would relate to that we spoke of in class is distillation, where you vaporize the liquid, turn to a gas, condenses, and forms back to a liquid. Distilled water is a very pure source of water. All right, if you're watching this, then you are probably preparing for a quiz. Most likely it'll be Wednesday here, as we usually do our assignments on Wednesday. So let's take a little bit of time to review the 3 classes of matter and what do we know so far. We'll start by reviewing a homework that you did. Many of you have it in Schoology. And we wanted to tell the difference between different terms. Remember, matter is anything that has mass and volume made of atoms, whereas energy does not. It is not made of atoms. So therefore, it does not fit into our classification system at all. It would just be outside of that. However, when we do classify matter, the first question we always ask, is it pure? or is it a mixture? So the difference between pure materials and mixtures is the composition. That means what they're made of. Pure materials are always made of the same thing, atoms or combinations of atoms. Mixtures vary. Elements and compounds are both pure. So what's the difference? The difference is the number of types of elements in them. Elements are one type of atom, compounds more than one. You could have a grouping of oxygen atoms that would be considered an element, whereas a chemical combination of hydrogen and oxygen could be water. That's a compound. Okay, so to review, some things you want to go through in your mind as you're given a material and asked where to classify is, number one, is this a pure material? Pure means it's the same throughout, everywhere, all the time. It's always the same thing no matter where you are. Is the container of whatever material you're looking at the same throughout? If yes, then you ask yourself, is this made of one type of atom, that's an element, or a combination, chemical combination of more than one type, that could be a compound? If you answered no to this beginning question, it wasn't pure, it has different properties throughout, or it looks different, you can see the parts, then that's a mixture. Now, some mixtures can seem to fool you because they're homogeneous. In other words, they do look the same throughout, like a glass of food coloring and water. However, there are mixtures that are a little more obvious that are heterogeneous. Heterogeneous mixtures, you can see the parts. In both cases, though, these are mixtures of things that don't combine chemically, such as water and salt. That's a nice homogeneous mixture, and a salad could be an example of a heterogeneous mixture. Let's quickly go through. In the homework, we had to find all the elements, compounds, and mixtures. Let's do the elements first. One clue that will help you is that there will be a symbol that you might find on the periodic table. So I'm looking for anything that has an atomic symbol, and sometimes there's two letters. The second letter is lowercase, indicating it's just the second part of that symbol. All of the following items are elements. All right, let's do the mixtures now. Mixtures often are also easy because there are things you can kind of think about as being a mixture. All right, let's look at a mixture of, let's say, ice cream, for example. Obviously, a mixture of sugar and milk and different things. Granite is a type of rock, but if you look at it closely, it's a mixture many people use for their countertop because of all the different colors and striping and patterns that you'd see of all the different minerals mixed together. Cheese is a mixture of milk and salt and flavors. Air is a mixture. Most people get this one wrong. They forget air is composed of oxygen as well as nitrogen, carbon dioxide, water vapor, and different pollution particulates. All right, a mixture of brass. Copper and zinc form brass, and a mixture similar to bronze. They do not chemically combine, and the ratios have to be pretty close for it to actually work and hold up. Same as steel. It's just a mixture of two different metals that actually are not chemically combined. Seawater is a mixture. Blood is a mixture. All right, now let's see what we've left here. We've left a few. Let's go back and see. Water is a compound. One clue is you're going to see a chemical formula. It's always H2O. It's never H3O4 or anything else. H2O. That's the clue that we're looking at a compound. Elemental mercury was skipped. That's clearly an element. Sugar has a formula, so we're going to keep it as a compound, as well as vinegar. Steam. Tricky one. Well, what's steam made of? Steam is made of water. Water is H2O. Methane has a formula. Salt was an example from our notes of a compound. In coffee, we left that out. Look at that. Water and coffee and sugar and whatever you add to your mixture. Ice is made of water. Again, they're hoping that you remember that steam and ice are just different forms of the same material. They're forms of water, which is H2O. All right. Good work if you got all those right. Let's take a look at another page in your packet. If you flip ahead past the lab, actually, you will find this page. It's a review. It also has some pictures that look like that on the bottom. Take a moment, look through your packet, see if you can find it. Again, we're going to do the same thing as far as ask ourselves questions if it's pure or not pure. So let's start with finding the pure materials. Diamonds and all the things that have elements or symbols can be listed as elements. Great. Let's look at some compounds. Do we find any pure compounds here? Chemical formulas is a sure sign that we have a compound. It's two or more different atoms in a specific ratio. It's always the same. And I'll try not to leave anybody out this time, but we never know. Okay, let's do the mixtures. Milk. There are different kinds of milk. You can get 2% milk, whole milk. It's water, protein, flavorings mixed up. Air, again, is a mixture. Gasoline. I see different types of gasoline, different octanes, different formulations. So gasoline in your car is a mixture. Let's go back to energy at the end. Let's do wood. We know it's a mixture. Different plant cells and water and different things in wood is along with popcorn. Okay. Now, we're missing a few. Energy and electricity are forms of energy. These do not fit in my common classification categories. So the directions say leave it with a letter X if it is none of these. Letter X, so I would put an X there. All right, let's take a look at the bottom level. We've got bismuth and uranium that we left out, and we've got a few more. Bronze, a mixture. To make that bell, you have to have the right combination of copper and tin. Ink could be a mixture, lots of different colors in there. Electricity, we put the X. A dog, strangely enough, is a mixture of blood, bones, fur, and maybe a bad attitude, depending on your dog. And concrete is little rocks and sand and cement to make concrete. Okay. How do we do these? Well, let's take a look. Anything that's a circle is an element. Two circles together touching means they're chemically combined. So let's see if we can find the pure elements. Pure elements. Choice C is the pure element. Mixture of two elements is choice E. A pure compound. Only one compound present. Okay, now I'm going to be looking at A and B here, but are there any differences? In A, we have a dark circle in the middle and a light circle. These are actually two separate, different compounds, so be careful. Choice B is correct. This is a sample of a pure compound. These could be all water molecules. A mixture of two compounds is A. And a mixture of a compound and an element is our choice D. One thing to be careful of, some elements will form a combination of two. So you might see two clear circles linked together. That actually could be an element. Oxygen often is found as two atoms of oxygen combined, but scientists still call it an element because it's just the same material. That's going to come to bear here as we try again with our circles to identify elements, compounds, mixtures of elements, mixtures of compounds, and mixtures of elements with compounds. So let's see how we do. This looks like almost like a water molecule. H2 and then O, a whole bunch of water molecules here. I'm looking at a compound. Here is a bunch of elements, but they're two different kinds mixed. We've got a mixture of elements. A compound, and then this, which looks like a compound, but remember they're the same thing, so scientists consider that an element. That's our mixture of elements and compounds. This compound and this compound are mixed. Maybe it's water and salt, just as an example. So that's a mixture of different compounds. Here is a lot of the same type of thing. That means it's an element. Here's a lot of the same thing. That's a compound. Again, these are all the same. That makes that sample an element. We've got an element and a compound. A mixture of an element and a compound. An element and an element. A mixture of elements. Two different compounds is a mixture of compounds. All of these are the same. These are different. Be careful. You could have two dark circles or two light circles. That's a mixture of compounds. These compounds also look similar, but it's two different compounds. Two different compounds and two different compounds. How'd you do? All right, we played GimKit in our class, and I will link some sort of game to a folder that will be entitled Review in the Classification of Matter folder. So you can play a game May or may not be GimKit. I don't know how GimKit works with just you playing, but we could try. So go ahead and study, review, prepare for that quiz. Remember the questions that you'll be asking yourself, and I'm sure you'll do fine. So thanks so much for tuning in, checking over this, and getting ready for this quiz. And hey, thanks for trying science. We'll see you next time.